So as the client moves away from the access point, they will shift down to lower bandwidth capabilities by using a process called dynamic rate switching. Okay, that is what is called DRS, dynamic rate switching, because when a client is moving further away from the access point, going to the corner of the BSS, they'll fall down a data rate. They'll connect to the lowest data rate, and they'll be able to communicate with the AP in that on that bandwidth capability, right? Now the access point can support multiple data rates depending on the technology that they're using, technology on the radio card there is. So a .11b radio will support approximately like 1 to 5.5 Mbps and 11 Mbps. In a way, let's take one more example of A. They support 6, 9, 12, 18, 24, 36, and 48 and 54 Mbps, whereas a .11g client supports both. So they support 1 to 5.5, 6, 9, 11, 12, 18, 24, 36, 48, and 54. So it's a combination of A and B which G supports, right? Now, depending on where the client is, they'll either be connected on 1 Mbps, 2 Mbps, 6 Mbps, 9 Mbps, depending on what technology they're using. And that's called dynamic rate switching between the in the clients. Of course, there is a correlation between the signal quality and the distance from the access point. As I said, as the mobile client device moves further away from the access point, both the AP and the client will shift to a lower data rate. Okay, just to make sure it becomes less complex. There should be less complex modulation, MCS rates, coding scheme. Let's say it's a possibility that a client at let's say there's a client here which is communicating with an AP at 30 feet. They may be transmitting at 11 Mbps, whereas another client here, which is let's say at a distance of 100 feet, they may be transmitting at a data rate of 2 Mbps on .11b radio. So there's definitely a correlation between the distance and the signal quality. That's what DRS is all about. And DRS is not something which is and it has different names. Some people call it dynamic rate shifting. Okay, some people call it adaptive rate selection. Some people call it automatic rate selection. There are different names to it, but the concept behind remains pretty much the same. They all refer to the same point that there's a speed fallback that happens on the Wi-Fi radio, on the Wi-Fi radio of anyway the incoming signal or the transmitting signal, depends on who's communicating. And in that way, the lower data rates will have a larger concentric zone, right, of coverage than the higher data rate. So in a way, what I'm trying to say is, let's say there's an access point right here, and let's take an example of .11b. Yeah, there's some kind of, I'm gonna squeeze that in here somewhere. Okay, good. So there's an access point right here and a client connected here and a client connected here, client connected here, and a client connected here. Now with an access point, this particular client might very well be transmitting at 11 Mbps, this at 5.5, this at 2, and this at 1 Mbps, right? So that's what I mean. So the lower data rates will have a larger concentric zone of coverage than the higher data rate. Clients at the corner connecting at 1 Mbps, the signal quality can be less, so they can be further away from the access point, and that is fine. Now just remember, a client when switches a data rate, okay, it doesn't move from 1 to 1.5. Okay, that doesn't happen. 1 to 1.5, no. 2 to 3, no. It has to move in the order 1 to 5.5 and 11. It can move from 1 to 11 directly, that's also fine. It can move from 2 to 11 directly, that's also fine, but any other number in between doesn't happen. So it has to be 1 to 5.5 and 11 in .11b, and as I said here on .11a is 6, 9, 12, 18, 24, and G so on and so forth. So they have to follow these data rates when they're falling, when they're falling down, or they're rising up. They have to connect on these data rates only. Okay, I hope this makes sense. Now, so what really matters is the RSSI value and to an extent the SNR value. When a client is at a low signal, what we mean is that the client has a lower RSSI value, and of course then it automatically becomes a lower SNR also, because they're all directly proportional. SNR, if you remember from our last videos, it is signal minus noise. Signal here is the RSSI value. So if signal is less, of course SNR would also become less. So that's pretty much what we rely on when we talk about lower data rate or a higher data rate. The client at a higher RSSI value and a higher SNR will be on a better data rate there. Now different vendors will implement this in a different way, right? So it's possible that DRS is implemented very differently by different vendors. So it's a very much possibility that you may have two different clients of different vendor. Let's say I have an Apple laptop here, or a MacBook here, and I have another Windows laptop here. Okay, now they are both at a distance of, for example, let's take an example. They're both at a distance of 40 feet from the AP. It's possible that the Windows laptops is communicating at 5.5 Mbps, whereas the Apple laptop is communicating at 11 Mbps, because the vendors implemented DRS in a different way. So this is very much a common possibility in every Wi-Fi network, and we don't need to really worry about this, but this kind of scenarios can happen in the Wi-Fi network. So we need to be aware of such scenarios and know what we want. Now, what I would suggest, and it's also a best practice, is to disable the two lower data rates when deploying a Wi-Fi .11b network. Example .11b network is this is what we discussed. I'm going to give an example of .11b. Disable 1 and 2, use 5.5 and 11. What I would do nowadays is, in a .11a network, I disable 6, 9, 12, and I keep 18 as the minimum enabled data rate in .11n or .11a. Similarly, for .11g, I would disable 1, 2, 5.5, 6, 9, 11, 12, and I will keep 18 as the minimum data rate to be enabled on a .11g network also. Now, there are other repercussions also of this, so we need to, again, I would ask you to go to the fundamentals course and see what data rates really are all about. If there is a client if there's a very old client in the network that only supports data rate of 1 and 2, then if you disable these data rates, they will not be able to connect, because a client hears the beacon of an access point at the lowest mandatory data rate. So when an access point sends out a beacon, the access point sends out a beacon at the lowest, most mandatory data rate configured. So if you disable 1 and 2, the clients that support 1 and 2, only 1 and 2, will not be able to even receive a beacon. So they will not see the SSID also. So yeah, so keeping all those things in mind, you have to make sure as a WLAN admin, you have all this information in the network before you go ahead and make any change available, right? Now, what will this do? So if you disable the lower data rates, what you're effectively doing is you are removing two concentric circles, right? From an access point, only 11 and 5.5 Mbps concentric circles will be formed. That way, you will not have a problem of sticky client behavior. Now, clients can be very adamant, okay? The client radio can be very adamant, and this is a very, very common problem that a lot of people face in the Wi-Fi network even right now. If you have a BSS which is very large, and clients at 1 Mbps are getting connected, because we support 1 Mbps at the corner, even if they're getting a better signal from a different AP somewhere here, which let's say they're getting around 5.5 mbps somewhere here from this AP, they'll still not fall onto this AP. That's the sticky behavior of the client's radio. They'll still prefer to connect to this AP, which is sending, which they're able to see at 1 mbps. That's the adamant in the sticky client behavior that is seen in a lot of client radios nowadays. And it's getting better with the new vendors coming in, with the new radio cards being made. But if you reduce the coverage cell and make it to disable the lower data rates, then the clients will be on 5.5 maximum, like minimum, and then they can easily fall onto a different client, different AP if they are near that client. Okay. And the second thing that we can prevent is basically roaming problems. With the same concept, roaming problems can also be erased if you have lower concentric circles with higher data rates available, so that roaming can happen easily and the client performance doesn't go really down. The other thing is hidden node problem. Now in the last chapter we discussed about some things we can do to mitigate hidden node. I did not discuss this on purpose. This is another way by which we can remove hidden node problems. Now if the BSS becomes small, the chances of a hidden node becomes less. Now an access point here, we discussed that in this scenario, if the BSS is too large, right, and this is at 1 mbps with the AP, and this also is at 1 mbps with the AP, it's possible that client number A may not hear the transmissions of client number B, right? Now if you reduce the coverage cell and client number A comes closer to, like, they are able to connect at 5 mbps only, 5.5 and not less than that, in a way, now these clients should be able to hear each other, and thus you are able to mitigate hidden node also in this network. So these three sticky client behavior we can solve, roaming problems we can solve, a lot of roaming issues can be solved, a lot of hidden node problems can be solved, and that way we are able to use and be proactive and fix a lot of issues that before even they arrive in the network. But yeah, you have to make sure that there is a proper site survey done. There is no escape to this. A site survey has to be done before you deploy any network. You have to ask many questions from the customer and understand what their network really requires, what their network really understands, and what their network really needs, so that you're able to deploy network with all the right information and all the right inputs from the customer. So anyway, be proactive, do these things in the network so that you're able to mitigate some problems before they even happen. And this is called being proactive, and this is a proactive approach, and this will take you a lot, this will save you a lot of time and effort when you try to troubleshoot and when you try to deploy a network. A right deployed network is going to save you a lot of time and money in the future. When you try to save some money initially and not get the site survey done, you think, okay, let's save some money here, we'll just deploy the network as we think is right, then your next few years will be very tedious. You'll be spending a lot of money and time on troubleshooting the issues, and the problem is the network is already live and you won't be able to make many changes because that's going to impact the production, which is going to make your life even worse. So might as well just spend time and money initially and get the right network and the right design done, then spend time on troubleshooting and save and making your life even bad for the future. So anyway, we'll discuss about roaming in the next video, and thank you.